Space. The final frontier. A vast expanse that stretches beyond our imagination. But what exactly is space, and why is it a vacuum? In this episode, we'll explore the mysteries of the cosmos and uncover why space is, quite literally, empty. To understand why space is a vacuum, we need to start with Earth's atmosphere. Our planet is surrounded by layers of gases, but as we travel higher, the air becomes thinner until it eventually fades away into the emptiness of space. Beyond the atmosphere, there are very few molecules of gas or other particles. This absence of matter is what we refer to as a vacuum. Unlike Earth, which is teeming with life and air, space lacks the elements that make up our breathable environment. Space is a vacuum because it doesn't have enough gravitational pull to hold onto gases. Planets and stars do, but the vast regions between them do not. This is why, when you're in space, you can't breathe without a spacesuit. The gravitational force of planets and stars attracts particles, creating atmospheres around them. However, in the vast stretches between these celestial bodies, there is no significant gravitational pull to gather and hold gases together. This lack of particles means there's no air pressure, no sound, and no breathable air. Spacecraft must carry their own supply of air and provide protection from the extreme conditions of the vacuum. Our spacecraft are equipped with advanced life support systems that mimic Earth's atmosphere, providing astronauts with the oxygen they need to survive and removing carbon dioxide from the air they exhale. Astronauts wear specially designed suits that provide pressure, oxygen, and protection from the vacuum. These suits are vital, as even a small breach can be catastrophic in the harsh environment of space. On Earth, we experience atmospheric pressure due to the weight of the air above us. In space, without this air, there is no pressure. This creates the vacuum, an area where the pressure is vastly lower than what we experience on our planet. The concept of a vacuum isn't unique to modern space. Even in the early universe, vast regions of empty space existed as matter began to clump together under gravity, forming stars and galaxies, leaving large expanses of nothingness. Space as a vacuum has fascinated scientists for centuries. It challenges our understanding of physics and pushes us to explore new frontiers. From the behavior of particles in zero gravity to the potential for life beyond Earth. Black holes, another fascinating feature of space, also contribute to our understanding of vacuums. These regions of intense gravity can even absorb light, creating areas where not even photons can escape, leading to near-perfect vacuums around them. While space is largely a vacuum, it's also a birthplace for stars and planets. Nebulas, which are clouds of gas and dust, can collapse under gravity to form new stars, showing that even in the emptiness, creation continues. Advancements in space exploration technology have allowed us to better understand and utilize the vacuum of space. From satellites that orbit our planet to probes that venture into the far reaches of our solar system, we're constantly learning more. Future missions to Mars and beyond will continue to rely on our understanding of the vacuum. Ensuring that astronauts can survive in these conditions is crucial for the success of long-duration space travel. The International Space Station is a testament to human ingenuity. It operates in low Earth orbit, providing a controlled environment where scientists can study the effects of living in a vacuum on the human body and other biological systems. Space is not entirely empty, though. It's filled with countless objects, from tiny particles of dust to massive asteroids. These objects travel through the vacuum, influenced by the gravitational forces of larger bodies like planets and stars. Comets, with their spectacular tails, are another example of objects that traverse the vacuum of space. As they approach the sun, their icy surfaces heat up and release gases, creating visible trails that stretch for millions of kilometers. Studying these objects helps us understand the composition of our solar system and the processes that govern it. Even in the vacuum, there is much to learn about the origins and evolution of celestial bodies. Beyond the visible matter, space also contains dark matter and dark energy. These mysterious components make up most of the universe's mass and energy. Yet they remain largely undetectable and contribute to the overall structure of the cosmos. Future space stations and habitats will need to harness our knowledge of the vacuum to create livable environments far from Earth. This includes understanding radiation, temperature extremes, and the psychological effects of long-term isolation. Living in a vacuum can have profound effects on mental health. Isolation, confinement, and the lack of natural environmental stimuli are significant challenges for astronauts, requiring innovative solutions to ensure their well-being. Creating artificial environments that mimic Earth is crucial. This includes growing plants for food and oxygen, using water recycling systems, and creating habitats that can protect inhabitants from the vacuum's harsh conditions. Our understanding of space as a vacuum also helps us explore beyond our solar system. The search for exoplanets and potential habitable worlds continues, driven by our curiosity about what lies in the vast emptiness. Discovering exoplanets in the vacuum of space has revolutionized our understanding of the universe. Each new finding brings us closer to answering the age-old question: are we alone in the cosmos? Probes and telescopes are our eyes in the vacuum. They travel vast distances, sending back data that helps us map the universe, study distant galaxies, and explore phenomena beyond our reach. The universe itself is expanding, creating even more vacuum as galaxies move apart. This expansion, driven by dark energy, continues to shape the cosmos and influence our understanding of space. Studying the vacuum of space and its role in the universe's expansion helps us understand the fundamental forces at play. It challenges our theories and pushes the boundaries of what we know about the cosmos. The vacuum of space is both a challenge and an opportunity. It represents the ultimate frontier, a place where humanity's curiosity and ingenuity are constantly tested. As we continue to explore and understand this vast emptiness, we unlock the secrets of the universe and our place within it. Thank you for joining us on this journey through the vacuum of space. Stay curious, keep exploring, and always look up at the stars, for they are the gateways to the mysteries of the cosmos.